I'm Henri Binsztok, or Henri in French. I'm the co-founder at OKcontract, and I'm going to talk today about dApps beyond HTML and JavaScript. So you may ask yourself, why this title, or what does it come from? And in fact, it comes from Vitalik, and thanks for writing that. Basically, that we need to go beyond HTML and JavaScript to write the business logic of dApps, and this is what's been missing in specification up to now. And I mentioned that we've been working on that at OKcontract. So why a new programming language? And we have something which has been happening. Like 50 years ago, you have been people writing assembly, and meaning that they need to understand everything that happened. But then came high-level programming languages, and then all these details could be somehow abstracted, and you wouldn't need to understand everything about the silicon to be able to program. And today, a new generation of languages is happening, in part because of LLMs. Because right now, I see a lot of younger developers, they just prompt LLMs to write programs, and they don't understand every single line of the program anymore. So it's a bit like you were programming in high-level languages and people make fun of you because you don't know assembly and the silicon. So, yeah. So this led us to write a new programming language, which we call LambdaScript, and which is a DSL, which we think has all the right properties to be the language to specify the on-chain interaction. First, it's a domain-specific language which has knowledge about what the blockchain is and which enables to bring additions to that knowledge, like now cross-chain, multi-chain. This is something that we can express. Then it's a purely functional programming language. So why? Because it enables proofs. It enables maybe later on to have ZK proofs of the execution of that program. It enables automated reasoning, so we can be sure more easily that it's the right interaction. And we'll speak about that in a minute. It's strongly statically typed, which helps a lot for LLMs, because if we annotate the types, then the LLM just understands it better. And it has order independence and other properties. I'll be speaking on Wednesday as well at the Stanford AI Summit with more details about that. So what does it look like? Here is the complete specification of an on-chain interaction with Uniswap v3, which involves no less than 4 smart contracts. You have the router, you have a quarter, and you have the 2 tokens. And here is the complete specification. Right now, if you look at the Uniswap front end, this semantics is split about 1,000 lines of JavaScript. And if you look at the front end, including maybe some lines in React hooks, which are really not easy, in fact, to understand or to put together. So this is very simple. What can we do in practice with that specification? Can we play the video? The video is coming, hopefully. Yes, 5 seconds is loading. So basically, with that same interaction, we have built a developer hub where developers can express and look at these interactions. Another thing we can do is automatically generate the UI from that specification using purely deterministic algorithms. There's no AI in that, sorry. Okay, internet is coming. And so basically we can generate the very short React, for instance, SDK snippet, which you just need to copy paste in your own code or an empty application and just run it. And you can have the same auto-generated interface. Now we switch to supplying lending on Compound. And this basically has been completely generated. You just need to copy paste the code and you have a front end. Oh, okay. What about something else? What's coming next? What's coming next is not only front ends, but AI agents, of course. And the good thing is we can take that same specification and provide it to AI agents so they can transact on chain. This was exactly what was discussed in the last panel. And basically, we are going to release an SDK with feature for agents extremely soon. We're targeting April 1st, so it will be a joke. And this is what the code looks like. So basically 5 lines of code. The only thing what matters is the interaction ID, which is the specification of that interaction. And we can embed it anywhere. And there's something else, and I finished by this, is we can do automated verification at the specification level. And this changes the game. For instance, something like the safe front-end attack, which played a backbeat, basically could have been avoided because we could check what's happening behind the scene. And we can build all together as a community, because Ethereum is a community. We can build a safe catalog of those interactions. We already support 2,000 contracts, but we can add many more to them. And check that these are the legitimate transactions and attest them. And we're already using EAS for that. So this is how basically, as a community, we can build this safe world of what we can do on chain. And we are building the foundations for that, the interactions for both humans and AI agents. So thank you, everybody.